Hello everyone, welcome back. We have learned the superposition theorem. Now let's apply it to this GATE ECE problem. This may not be the fastest way to solve this particular problem, but that's not the point. The goal is to understand how the superposition theorem is actually applied to a real GATE problem. Consider the circuit shown in the figure. We need to find the value of V0 rounded off to one decimal place. Here we have three independent sources: 4-volt voltage source, 6 milliamperes current source, 2 milliamperes current source. According to the superposition theorem, we consider one source at a time, find its contribution to V0 and then add all the contributions. For an inactive ideal voltage source, we replace it with a short circuit. For an inactive ideal current source, we replace it with an open circuit. So, V0 equal to V01 plus V02 plus V03, where V01 is the contribution due to the 4-volt source, V02 is the contribution due to the 2 milliamperes source, V03 is the contribution due to the 6 milliamperes source. Now, consider only the 4-volt source. Deactivate the current sources. The circuit now reduces to two 1 kilo ohm resistors in series across the 4-volt source. Since V0 is across the second resistor, we can use the voltage divider rule. As per the voltage divider rule, for two resistors R1 and R2 connected in series across a voltage V, the voltage across R2 is V into R2 divided by R1 plus R2. Therefore, V01 equal to 4 volt into 1 kilo ohm divided by 1 kilo ohm plus 1 kilo ohm, which is nothing but 2 volts. Now, consider the 2 milliamperes current source. Deactivate the other two sources. The 2 milliamperes current divides between the two equal 1 kilo ohm parallel branches. We take the downward direction through the middle resistor as our reference direction. The actual 2 milliampere source current is upward, opposite to our chosen direction. Therefore, with respect to our reference direction, the total current is minus 2 milliamperes. We use minus 2 milliamperes because the actual source current is opposite to our chosen reference direction. Now, using the current divider rule, the current through the middle resistor is minus 2 milliamperes into 1 kilo ohm divided by 1 kilo ohm plus 1 kilo ohm. So we get minus 1 milliamperes. The negative sign tells us that the actual current flows upward opposite to our downward reference direction. The voltage V0 is defined with plus at the top and minus at the bottom. Since our current reference direction is downward, it enters the positive terminal of the resistor. Therefore, using Ohm's law, V02 equal to the current passing through this resistor into 1 kilo ohm, that is minus 1 milliamperes into 1 kilo ohm, which gives us with minus 1 volt. Now consider only the 6 milliampere source. Deactivate the other two sources. Now look at the 6 milliampere source. An ideal current source forces a current of 6 milliamperes through its branch. The arrow of the source points to the left. So, the 6 milliamperes current enters the V0 node. That same 6 milliamperes must then leave the V0 node through 1 kilo ohm resistor, because a current source always maintains a constant current throughout its branch. Therefore, no current flows through the two lower vertical branches. Hence, the current through the lower branches will be 0. Then using Ohm's law, which is V equal to I into R, V03 equal to 0 into 1 kilo ohm, which is nothing but 0 volts. Now, let us add all the contributions. According to the superposition theorem, we add these contributions algebraically. So the final answer we get is 1 volt. That's all about this video. I'll see you in the next one.